Hello students, in this video I'm going to talk about the concept of the unit circle, and the main two things that we are going to discuss here are going to be radians and degrees. So till now in middle school and some years of high school geometry, you have looked at the unit to measure angles. So there are basically I think 3 to 4 units to measure angles, gradient, different units that help you understand the measurement of an angle. Anywhere you see angles all over the world, everywhere in buildings you see angles. The roofs are at an angle. So the very basic unit you have used is degrees. And one circle, we look at when we look at radians, the idea of circle will make more sense, and you will see why it becomes very convenient to use radians in higher math, calculus, pre-calculus, as compared to using degrees. So the application of radians, it becomes very easy to use in higher math problems, and the use is a lot as compared to degrees. So one circle is 360 degrees. I hope you understand that. So if we are starting from 0 here, half of the circle is 180 degrees. Now, 1 degree you already know from a protractor. If you are in a if you were in a geometry class, you know there is some measurement of this is 0, this is 1 degree. Drawings not drawn to scale. Now we are going to look at radians. Now radians, another way to write is RAD. That's the unit of radians. And the meaning of radians is basically that whenever, let us say I'm taking a circle over here, I'll just try to erase this information for now. And if I take a circle with a certain radius length, and the angle that is formed at the center of the circle, subtended at the center of the circle, let us say it's theta we are taking for now. Now the angle that will be formed, that is the length of exactly, the arc length will be exactly the radius. So that angle which is measuring the exact same length as the radius is going to be 1 radian. So I want to repeat myself again. The drawing is not drawn to scale because you're seeing longer radius here and not so long length here. Or we can just try to make it a little bit closer to scale, because I feel the radius is really long right here. So I'm going to take some length here, longer length, and maybe that sounds right here. All right, so that angle theta is going to be equal to 1 radian whenever this distance, the arc length of this angle subtended, is same length as the radius. So whenever that happens, the angle subtended is always equal to 1 radian. All right, so that was our first point, that 1 radian will be whenever you have the radius length subtended. Radius length is basically equals to your arc length, and that is the angle 1 radian formed at the center of the circle. Now students, let us take a little bit more understanding into the radian and why 180 degree is going to be pi radians. So what we do is, if I take a circle with radius, how many radius can I have in half of the circle? Because half of the circle is 180. So let us say I have another radian going exactly same length as R. This is my radius. Again, drawings are not drawn to scale. This is just so I can explain it to you. So this is again 1 radian established. So I have another third radius length that I can have. So what happens is, students, that I can have maximum of 3 radius subtended as the arc length and a little bit more. So that is actually the definition of pi. So I'm looking at 1, 2, 3. And then I have 0.14159 is the amount also that I'm subtending here. So that is nothing but your definition of pi, 3.14159, and so on and so forth. Irrational number, it never stops. It'll keep on going, but we have always taken in as 3.14. Again, the radian also helps us understand the definition of circle, half a circle. How many radians can I have in half of a circle? 1, 2, 3. And then a little bit more, which gives me 3.14159 as the approximate value, and that is nothing but pi. So that is where the pi is actually originating from. All right, so that was the basic information about radians. And let us say we have to find out the number of radians if I have the given number of, let me draw the line here also just for center, although, all right. So let us say, students, we have a radius. I guess I did not select the pen. There. So we have the radius, the center of the circle at O, and the radius given is 5. Now let us say they are asking me that they are subtending a certain length on this circle, and then the end of that line on the arc length is going to make an angle with the center of the circle. So they're asking me, what is this? But once I know this information, what is the length of the arc? Let us say the length of the arc is S, which is 10. So it's actually the double of the radius. So if that happens, how much is of the angle am I subtending? So my answer will be the angle theta is the arc length divided by the radius of the circle, which is going to be 10 over 5, which is 2 radians. So that means I have actually subtended the length 2 radians here, and then once I have a little bit more and 0.414, I will be subtending pi radians. So always remember that 180 degrees, there is another thing that we found from here, is pi radians. So we looked at the definition of 1 radian, then we looked at pi, and then we can also turn this circle around and we can look at 360 degrees. So I hope you agree with me that over here our 360 degrees is going to be 2 pi radian. So that means whenever I'm converting, students, I can always use 180 degree as pi. And that's going to be very useful for us when we understand the number of the conversions that we'll do on the next page. So basically 180 degree divided by pi will give me 1 radian from this formula. And pi divided by 180 will give me 1 degree. All right, so let me get all my hard work go away over here so we can practice some examples. So you can see it fly away. There goes our unit circle gone. Now I'll have my pen ready and we'll practice some examples. So again, just for understanding purposes, radians to degrees. Our concept is the same, but I was just giving you some information about radians and where it's actually originating from. Radians to degrees and degrees to radians is what we will look at on this page. And for example, we have our question as that we are converting is going to be 7 pi by 4. So students, an easy way to convert is it's already in radians, you can see, and they want us to convert it to degrees. So instead of pi, the easiest method is we just looked at on the last page, the pi value is what? 180 degrees, correct? So instead of pi, I can apply 180. So here I'll have 7 times 180 divided by 4, which is going to be 1260 divided by 4, and that is 315 degrees. So as you can see that it is a little bit more than 180 degrees, 315, which is going to be very close to 360 degrees, but that is the answer. All right, let us practice another one, 3 pi by 4. So it's in radians, it's in pi. So let us change into degrees. Instead of pi, I can apply 180. 3 times 180 divided by 4, which is 540, because 18 times 3 is 54. divided by 4, and that should be, sorry about that, 135 degrees. Let's practice one more, students, then we'll move on to degrees to radians. Oh, I just wrote down degrees to degrees. Sorry, my bad. Degrees to radians. Okay, let us do an easy one, pi over 3. Very easy. Pi is 180 degrees. I'm sure you know the times table of 3. 3 times what is 18? 6. And the 0 just slides in with the answer. So it's 60 degrees. So go ahead, pause and take notes on these. These were just 3 examples that I did, and I hope it makes some sense. We'll move on to a couple of examples, but before that, I gotta let us see this fly away. There it's gone. All right, now we are going to convert, students, degrees to radians. Now for degrees to radians, you need to understand 1 degree equals pi over 180. Because pi equals 180 degrees. So if I am looking at 180 degrees, in order to find the value of 1 degree, I will just divide both of the sides with 180. So it's gone over here, it's 1. So that's my formula, that is pi over 180. All right, so our question here is going to be, we have to convert 45 degrees into radians. And what we'll do here is we'll just multiply our degree value with our formula, pi over 180. We don't have to do anything with the pi. We just have to simplify the question. So what you can do is you can use your calculator, but I'll suggest try to do it on your own. This will divide by 5. 5 times 9 is 45, and 5 times, oh, I can even divide it by, 9. I just saw that it will be divisible by 9 as well. It'll make it easier. 9 times 5 is 45, 9 times 2 is 18, gone. 5 times 1 is 5, and 5 times 4 is 20. So that is pi over 4 radians. So that means on your unit circle, when you have traveled 45 degrees in radians, how much have you traveled? You have traveled pi by 4 radians. All right, next up, we have 150 degrees. So for 150, again, the method remains same. We times the degree value by pi by 180, our formula that we used derived here. Zeros and zeros is easy. They can go away. Just by looking at it, I can see that they both divide by 3. 3 times 5 is 15. 3 times 6 is 18. They are, can no more be simplified. So the answer is 5 pi by 6 radians. So hopefully, students, this was a learning session for you. Again, remember, pi is 180 degrees. And we also looked at the proof as to pi, why is pi 3.14159, so on and so forth. And that is the reason, there's a cool thing that on 14th of March, 314, everywhere in the world is celebrated Pi Day. So we can have some apple pie on that day. All right. Hope this was a good learning session. Your feedback is important to me. Please feel free to like, share, subscribe, and happy learning. Math is fun. Bye. See you in my next video.